So dimensional analysis is one of those things when you're like, your professor is talking about it and you're like, this is stupid. And then you get a real job and you're like, oh my gosh, I'm actually using this, because it's one of those things where like, you're like, what is this equation even for? Because someone hands you an Excel spreadsheet with some kind of a weird built-in equation and you're like, what is this even measuring? And then you go through all the dimensions. You're like, oh, that's what it is. Okay. So let me kind of show you what I mean. So like if you have something, it's all about what are we measuring, right? So if I have cubic centimeters, like, okay, I got that. It's a volume, yay. Or if I have, kilograms per cubic centimeter, then I could say, okay, well, that's mass and that's over volume. Oh, yay, that's density. Okay. So it's kind of like hacking your equations and just kind of knowing what you're even getting. This becomes a huge deal in mechanics and materials. Is like the first time that I got serious about dimensional analysis. Okay. So like, let's say you've got some kind of equation, you're just following the units and you've got foot times inches times hour over centimeters times seconds. Okay, well, obviously, if you're just looking for like, what is the general idea of what's going on, these are both times, so the times cancel out. I mean, they don't really cancel out, you'd have to convert between them. And then at least one of these distances cancels out. So essentially, you're left with a distance. So really, probably instead of doing that, what I should be doing is going distance times time over distance times time. So these would go away, and so you have a messed up distance. So it's a messed up distance because your units are all messed up because you have feet inch second or feet inch hours over centimeter seconds, but in general, what you're doing is a distance. Okay, so it kind of comes down to the idea, and that's kind of what I was talking about. Are we looking at stuff that is dimensionally consistent? So let's say you've got some kind of thing where, okay, well, I've got this equation, and I'll say, okay, so y is going to be equal to x over t plus ft over m. And you're like, what is that? That doesn't look like any kind of equation I've ever seen in my life. So the question is, what is y? I don't know what y is. Okay, but I can go, okay, well, I've got a distance, and for me, it's just easier just to use like meters, I guess. So I've got something I'll pretend is meters over t. I didn't actually write that down, but that's a time. Let's just say x over t might be like meters per second. And you can do this in like miles per hour or whatever. I just like to use meters because it's less to write, I guess. And then a force is measured in newtons. And then time is measured in seconds. And then m is the mass, so that's measured in, say, kilograms. Okay, so that means I have, and I don't know why I put them in these little, what you call them, it's like greater than, less than signs. It's something that I've always done. And I'm sure at some point someone told me that I was supposed to do that. So a newton is a kilogram times a meter per second squared, like that, right? And let me write the squared on the outside. Squared, and then times seconds over kilograms. And if these little thingies are bothering you, just take them out and just do meters over seconds times kilogram meter per second squared times seconds over kilograms. And then what you end up with is, so I'll just do that now, meters per second plus, no, I don't like the way that looks, meters per second plus, let's see, so this second and this squared would cancel out, and the kilograms over the kilograms would cancel out. So I've got, maybe, I think so, meters per second plus meters per second. Oh, okay, so meters per second, that's a velocity. And so that's what dimensional analysis is basically doing. It says y is a velocity. So whatever this was, I was obviously measuring a velocity. So that kind of make sense. Yay. Okay. All right, so let's do kind of another one. And again, this is just the point of dimensional analysis is kind of like, I guess, a dummy check on like what it is that you're doing. Like, does this even make sense? Whatever, are we even getting answers that are remotely anything? All right, so let's say I have A is equal to F times M plus X over T squared plus VT. All right, so I'm going to try writing it without the weird little squiggles on it. It's going to drive me nuts. Okay, so force is measured in newtons. And then, oh, I can't do it. I'm sorry. Merps. Newtons. And then mass is in kilograms. And then x is a distance, so we'll say that's in meters. Time is in seconds squared. And then velocity is meters per second. And then time is seconds. Okay, so let's see, what do I got right here? Okay, so newtons, I could rewrite, I'll just rewrite it as kilograms times meters per second squared. Yeah, so this is where you start to get like a little like, so right here I have some kind of square kilogram, I have kilogram per second squared times meters, which, I mean, already I'm kind of like, I have no idea what that would potentially be. I'm sure someone in the comments can help me with that. Maybe that's something you've seen before. But then this is going to get worse because I have a meters squared over, no, just meters squared over seconds. Okay, meters over second squared. I know that. That's acceleration. Okay, so this is an acceleration, which unfortunately doesn't match this. I can't add random thing plus acceleration. That would be like adding, you know, chickens to Hogwarts. And it's just not a thing. So yeah. And so then over here, the seconds would cancel out, which is, I guess, okay. And I ended up with just meters, which is a distance. So what is chickens and Hogwarts plus acceleration plus distance? It's called nonsense. So I must have copied the equation down wrong. This is basically what happens when you see this, is it should be a minute for you to go, okay, so clearly I need to go look this up again because I've completely missed something, or F doesn't actually stand for force, it stands for flummoxy blah blah, and V doesn't stand for velocity, it stands for something else entirely, and then that's how the units would work out. But definitely with what I made assumptions on, this equation makes no sense. So again, in case this is not clear why you can't do this, it's just like, I can't say 3 inches plus 6 feet, because you're, okay, I mean, you can, except you'd have to convert, right? So you'd have to say, like, 3 inches is a quarter of a foot, right? Because 3 times 12, 1/12, yeah. So a quarter of a foot plus 6 feet, and then you could say, oh, that's 6.25 feet. That is fine, but what you can't do is you can't say, okay, well, I've got 3 inches and 6 feet, so that's 9 inch plus feet. I don't, like, those units don't make any sense. Yeah, no, this makes me a sad panda. Okay, so you can't add stuff if it's not the same units. Okay, so pretty common thing whenever you're working on dimensional analysis is just kind of practice and say, okay, can you either do the conversion or is it totally not possible? So let's do a couple. So you might have something like this. If you can, I would recommend pausing the video and just trying to work these out on your own and see how far you can get. Okay, so we'll pretend that that happened. Okay, so let's look at this first one. Dimensionally, it makes sense. I have a volume per second. So I have a volume per second, or time, a volume per time, and this is going to be a volume per time. So this should be a totally doable thingy. Okay, so a couple of ways to do these, and this wasn't really meant to be a unit conversion practice, but you might as well. So I'm trying to get to hours. So there's 3,600 seconds in 1 hour, and that will make the seconds cancel out, so that's good. And then in feet, there are, oh gosh, there's 3,000, no, not 3,000, 5,280 feet in 1 mile. So, oh, why am I doing that and then converting? That's dumb. Let's use the other one. I know how many meters there are in a foot. I'll just do that one. So there's 0.3048 meters in 1 foot. But since that's cubed, I've actually got to cube the top and I got to cube the bottom to make the cubic feet cancel out. Okay, and then I have meters and I need to get to kilometers. So I know that there's 1,000 meters in 1 kilometer. But again, I got to cube them. Okay, so that the meters in the meters cancel out. So without too much trouble, I can come out and I can get that that's going to be 1.52 times 10 to the negative 10. It's super tiny, but it's there. Cubic kilometers per hour. Okay, so that's, as in case you've forgotten how to do that, that would be how to do. The biggest problem that most students will do is they'll forget to do these cubes. I mean, I guess for the one it doesn't matter, but they'll drop these cubes. So I'll actually see people that'll just write it 3 times so that they don't forget the cubicness. Okay, now this one, cubic feet to square meters. Well, this is a volume, and this is an area, so it's a no-go. Okay, this is your sad panda kind of thing. Okay, this one is cubic feet per inch, which can kind of give you pause. You're like, what's a cubic foot per inch? But what it is it's a cubic distance over a single distance, which means it should be a square distance. And that is a square distance, so we should be good to go again. So dimensionally, that makes sense. And then all we would have to do is actually do the math. So 8 cubic feet per inch. It's a stupid thing. And I mean, hopefully nobody's giving you formulas that look like that. Let's see. I'm going to cancel out the inches, and I'm going to cancel out one of the feet. So now I have square feet. I'm just going to kind of do an intermediate step. So that should be what? 96 square feet? Yeah, 96 square feet. And so now I need to convert 96 square feet to meters, which is much easier. 0.3048 over 1 foot. And then I'm going to square everything. Square, 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 square. And then the feet squared, cancel out with that feet squared. So I've got 0.892 square meters. So that's what we mean with dimensional analysis, is just kind of looking and going, do these things even make sense? And honestly, this whole unit conversion thing, the time I've really used it the most is, I swear, when someone hands me an Excel spreadsheet and they're like, I can't get my answer right. And I'm like, well, because if I actually look at all the cells that you're adding together, you're getting goblets per chicken head base. I don't know what's with goblets and chickens, but that's the point. So dimensional analysis, I think, is this unsung hero of just kind of having any idea what you're talking about.